Welcome to Quantum Statistics, Introduction to Macrostates and Microstates. So let's start with some definitions. Capital S is the number of total macrostates and capital N is the total number of particles, where it is equivalent to n sub 1 plus n sub 2 plus n sub s, where n sub s is the number of particles in macrostate S, and g sub s is the total number of microstates in macrostate S. So let's move on to our examples. Let's say, for example 1, find capital N, or the total number of particles, capital S, the total number of macrostates, N sub S and G sub S if the large boxes represent macrostates and the inner boxes represent the microstates. What we need to do is to assign the states their number. So let's say for box 1, this is state 1 or macrostate 1. Box 2 is macrostate 2. And box 3 is macrostate 3. So we have S, capital S is equivalent to 3. Now for microstates, we can write G sub 1 for state 1, G sub 2 for state 2, and G sub 3 for state 3. What we need to do is to count how many smaller boxes are there in each of the macrostates. So for state 1, we have 2 smaller boxes, which means we have 2 microstates. For state 2, we have 3 smaller boxes, so we have 3 microstates. And for state 3, we have 1 small box, so G sub 3 is equivalent to 1. Now let's find the number of particles for each of the macrostate. N sub 1 is equivalent to 1, 2, and 3 particles, so we write here as 3. For N sub 2, total number of particles in macrostate 2, we have 1, 2, 3, 4, 5, and 6, so we write here 6. And for N sub 3, or the total number of particles in macrostate 3, that's equivalent to 4. To calculate the total number of particles in all of the states, capital N is equivalent to N sub 1 plus N sub 2 plus N sub 3. Now we just copy the numbers written above. So this is now equal to 3 plus 6 plus 4, which is equivalent to 13. So now we have found the total number of particles N, which is 13. S, capital S, which is equal to 3. And all the N sub S, as well as all the G sub S. That solves example number 1. Now let's move on to example number 2. We have the same problem, but we have a different set of boxes shown in the bottom of the page. The same thing, we have to assign each of the boxes their own macrostates. So let's say this is state 1. Next box is state 2. Next box is state 3. And the last box is state 4. Therefore, S, capital S, is equal to 4. Now let's find how many microstates are there in each of the macrostates. We can write G sub 1, G sub 2, G sub 3, and G sub 4. Since there are 3 smaller boxes in state 1, G sub 1 is equivalent to 3. For state 2, there are also 3 smaller boxes, so G sub 2 is equivalent to 3. For state 3, we have 2 smaller boxes, or 2 microstates, therefore G sub 3 is equivalent to 2. And lastly, for state 4, or macrostate 4, we have 1 box, or 1 microbox, therefore G sub 4 is equivalent to 1. Now let's find how many number of particles are there in each of the state. So we write n sub 1, n sub 2, n sub 3, and n sub 4. For n sub 1, we have 3 particles in state 1, so you write n sub 1 is equal to 3. For state 2, we have 6 particles. For state 3, we have 4 particles, and for state 4, there's a total number of 3 particles. Now, calculating the total number of particles for all of the states, capital N is equal to n sub 1 plus n sub 2 plus n sub 3 plus n sub 4. Remember, we already have those numbers shown here. So we just need to write that down. N sub 1 is equal to 3, n sub 2 is 6, n sub 3 is 4, and n sub 4 is 3. Therefore, the total n is equivalent to 16. Total S is equivalent to 4. All the n sub s are already accounted for, and also all the g sub s are also solved. That solves our example 2 problem. Thank you for listening.